Welcome everybody. It's a pleasure for me to be here, at least online. So now I am in the Czech Republic. So now it's getting quite late, but I'm happy to be here. So let me share my screen. I would like to speak about firstly geometric construction in the plane. So I will share the screen firstly. I hope that you can see it now. So
yes, we can see you.
Okay, perfect. So firstly, what I am using GeoGebra for in my lessons. Firstly, let me introduce myself a little bit because probably some of you know me, but I'm teaching at university. My students are prospective teachers of mathematics. And at the same time, I am a secondary school teacher. I'm teaching mathematics and informatics at grammar school here in the Czech Republic. So it perfectly complements each other because I'm secondary school teacher. I'm preparing at university future teachers for their careers. So I think I can show them what are the problems, what they have to deal with when they are teaching at secondary school. So firstly, what I'm teaching at university regarding kinematic geometry, and in this topic, I'm using GeoGebra a lot because it's perfect tool for showing kinematic geometry in the plane. So this will be the first part, constructions of particular planar curves using GeoGebra. And second, a 3D printing with GeoGebra, because I can prepare some models in GeoGebra and then we can print it. And this is the topic what I'm using at university and also at grammar school. So I'm combining these two fields, mathematics at university and mathematics at secondary schools. So firstly, kinematic geometry. This is the outline of the presentation. I think we are sharing this material so you can see it whenever you want. And what is kinematic geometry about? So firstly, some practical applications, why we are teaching this topic. So here you can see that kinematic geometry and also geometry in general can be seen in many practical applications, like some medical tools, medical machines, gears, and some mechanisms. So I think there is no doubt that geometry is very practical and very useful for many fields. What is kinematic geometry about? We are speaking about some curves, about points that are moving in the plane. Of course, we can go also to higher dimensions, but now I'm only in the plane. So any point of the moving plane is describing a curve. So here you can see some example. If GeoGebra will work, yes. So let's say point C will be moving in the plane and it will draw some curve. And then we can also see what some curves are drawing. So a curve can move and it's describing another curve, which is called envelope. So points are drawing trajectories and curves are drawing envelopes. So I will show you this example. So I'm moving with a point. It's done with some trajectories of point A and B, and you can guess what the point C will draw. So I think you know this example that point C is drawing the ellipse. And also you can see what some curve, another curve here is an example of a line, that this line will be draw some envelope. Envelope is a curve which is in every moment touching moving curve. So here a plane, here a planar, here a line. So this is the topic, what is it about, kinematic geometry, and some theory with what is behind. So how we can determine the motion, for example, with two trajectories. So you can see here, two trajectories of two moving points are given. Or we can say that the motion is given by two envelopes. So here an example that two lines are still touching two curves, which are envelopes for these lines. And then the motion is given. Also, we can combine these options. We can have trajectory and envelope. So point is, sorry, I forgot what is moving here. So a line is still going through some point, which is an envelope of that line, and a point A is still moving on a circle, which is a trajectory. And the final way how to determine the motion is with fixed and moving centroid, which is also a very nice practical example of kinematic geometry from very practical example where some circle is moving without sliding, without how to say it, still this arc on the circle is the same length as this segment line. So this is the final way how to determine the motion. And then we can talk about special motions in the plane, and still GeoGebra really helps here a lot, because when I'm just drawing such examples by hand on the blackboard, I never can draw all positions. So GeoGebra really helps here. So here you can see, for example, elliptic motion. Again, two lines are given as trajectories, and we can see what it's going here. Also, we can change the determination of the motion, that we can also say that this motion is given by two circles, where one circle is moving inside the second circle, which is of double the radius. And we can also get this motion. Again, many practical applications of this. Or cardioid motion, which means that 2-point envelopes of two straight lines are given. So again, I can see two lines, red lines are still going through 2 points, and we can see that green point is drawing some special curves. Or cycloidal motion, which I have already showed you. Circle is moving, is rolling on a fixed straight line. Or actually, this is an inverse motion of cycloidal motion, that a straight line is rolling on a fixed circle. And we can get the curves which are called involutes. Hypocycloidal motion. And I really like these pictures in GeoGebra because I can really show you here I can move with the circle. Now I'm afraid that the internet connection is quite slow, but you can try it on your computer, these examples. I can also change the distances of a point from the center of the moving circle, or I can also change the radius of a circle which is moving or which is fixed, and you can get really beautiful pictures, what you can never draw by hand. It's really difficult. Or pericycloidal motion, which is given that a circle is rolling on a fixed circle. Again, you can see that motion. Or epicycloidal motion, for example, a circle that is rolling on a fixed circle. So this is it. And finally, conchoidal motion, where a point envelope and a trajectory are given. You can see here that a straight line is a trajectory of some point, and this line is going through a point, and we can see the trajectory of point C. So this is the these are special motions in the plane, and we can, for example, study what kind of curves we can get with these motions. We can actually by hand, we can construct trajectories or envelopes. Again, GeoGebra can help here a lot. Or we can find constructions, or we can deal with constructions for finding the center of curvature of some curves, trajectories, and envelopes. For example, if we are considering this cycloidal motion, we can try to find these cusps of the cycloid. Or we can have some constructions for finding centers of curvature, as I said, and the circle. The circle, which is actually the centers of curvature and the circle in it. So here another example, epicycloidal motion, and the centers of curvatures are determining this violet curve, and it's the it's the whole curve. So we can really do a lot with GeoGebra, and it's helping a lot. But this topic is for university students. What I'm also doing at secondary school. So it's, for example, the topic of inscribed and central angles. So here you can see the inscribed angle theorem. So I have a circle point moving on that circle, and we can see that this angle is still the same. I can also change the determination for showing Thales theorem, for example. As you can see here, that this angle is a right angle. Perfect. Imagine that you have to draw this on the blackboard by hand, and it takes time, of course, but GeoGebra is like a magic, I would say. So this is what I'm doing in planar geometry with my mostly university students. And I would like to also show you what I'm doing with GeoGebra regarding 3D printing. So I will change the presentation. And sorry, I closed the window, so I have to find it. So GeoGebra conference here. So regarding 3D printing, I think I don't have to tell you what is it about. So here is just the illustration how to get from digital model, how to get a 3D printed physical model. So on some printer, I'm using this printer, which is Felix, but there are majority of brands what you can use. And I'm pretty sure you had already seen 3D printer in progress, so I will skip this video. And I would like to speak about how to get the digital model for 3D printing. So you can use, for example, 3D scanning, which is very useful when we want to get real replica of some real object. So for example, contact 3D scanners or optical 3D scanners, and we can get points which are on the surface of that real object. And then with some other processing, we can get digital model, which is possible to print. You can also use, for example, laser scanners. This is quite interesting, but I would say difficult topic, at least for secondary school students, because the process of getting digital model from the point cloud, what we get from the 3D scanners, is quite really difficult. So we can use GeoGebra. for 3D printing, because I will show you directly in GeoGebra that you can draw anything what you want. I will draw something very simple, for example, a cube. And if you have this digital model, as Steve already said, you have to remove everything what you do not want to print. So for example, show plane I will remove, and also axis, otherwise it will be in the digital model and I would print it also. And now if I have a model, I can just download it as STL format, which is a format where the information about the model are saved. It's like a triangle mesh, which is representing the model. So once we have a 3D model in STL format, we can use some slicing software, and we can directly print it on the 3D printer. So here I can show you that using slicing this is another model that we are counting how fast, in what quality we will print the model. So it's perfect. GeoGebra is very simple to use also by students. So when I'm teaching this and preparing some models for teaching, also my students are using GeoGebra. They are preparing the models for printing. So they are helping me. It's not only that they are just watching what I'm doing with 3D printing, but they can join the process of designing, at least with GeoGebra. Of course, there are also some other programs, not only GeoGebra, but also another professional modeling software. So I just wanted to show you that also, for example, rhinoceros I'm using for 3D computer modeling. So slicing, we have already prepared the model for 3D printing. So I would like to show you what I am using, these models for. I'm not sure if you can see me on the camera. For example, at secondary school, I'm printing. Maybe I will stop blurring my background. So for example, such models. So for example, when I'm teaching 3D geometry, I'm showing students, every student can have this model and hold it in his hands or her hands, and they can use it, and they can see, for example, some properties, relationships between geometrical objects. Here I'm showing the positions of some two lines. What I'm also doing, because I'm dealing with this also in my research, I'm, for example, comparing what is better, if to use digital model, as you can see on the left in GeoGebra, the situation is depicted, or if it is better when students are using real physical objects. I'm doing some research on this. I'm comparing what is better for students. So here, for example, can see the situations that students are asking about the positions of two lines. The task is depicted just in the plane, and what is better, if they can use also physical model or if they can use digital model, and if they are able to determine what is the situation in the picture. What next I'm using? I also, together with my secondary school students, we prepared a project, because in the Czech Republic, I'm not sure how it works outside the Czech Republic, but in the Czech Republic, there are companies which are producing 3D printers, and they are offering the possibility that if you have some projects, some ideas for what you would like to use 3D printers, you can get 3D printers for free if they like your project. So together with my students, we designed a project for tessellations. Here you can see on the picture. And for these wireframe models of pyramids and cubes. So, and they really like it, the company, and we really got the 3D printer for our school. So the project was this project consisted of 2 parts. I would call it like construction set of polygons for tessellation, for tilings. And the second was those wireframe models. Actually, tessellation, tilings in the plane, it's very nice geometric topic. It's actually based on some symmetries or transformations. So here you can see the inspiration of Escher, if you know, very nice geometry. This is based on translation, or here tiling based on rotation, or here translation and also symmetry, axial symmetry. So then we can get very nice tilings. Also, I can show you that we were printing this on the printer, and you can get really like a set of constructions for students, and they can really see that it works there, and nice geometry is behind. And actually these pictures and these models, digital models for 3D printing, I and my students modeled in GeoGebra, which is very easy because you can model straight lines, you can use some transformations, and you can get planar image. And if the 3D model has some thickness, of course, it cannot be just in the plane. We are just using printing of solid figures, because it has to have some thickness. And the second part of the project was were these wireframe models, pyramids, and as you can see here. And this is a cube, a model of a cube. So this is actually secondary school mathematics, and I'm also using models for university students. So here you can see some more complicated digital, actually printed models. So some models of ruled surfaces, as Steve also shown. Or here you can see another examples of models, more likely for secondary school mathematics. But what I really like, that it's not just a drawing, or it's not just a digital model. We can really touch it, we can have it in our hands, and I think this is always a better situation, better way how to learn what holds in the 3D space, what are the relationships between objects, and we can actually see and use more senses, not only that we are watching on some construction. We can really touch it and have that experience. Here you can see another models. This is also possible to model in GeoGebra, because we have parametric equations for all of these models. Actually, these are helical surfaces, and down you can see ruled surfaces. So we have parametric equation, and if we are able to describe it with mathematical equation, we can print it because we have a digital model. So what I would like to do in the future is, it's clear actually, I would like to extend my gallery of models. I would like my students to join, and they are already joining me, they are helping me. And I think when they are really using modeling, they are printing the models, they can really see how it works, they can really enjoy the geometry, and I think they are learning geometry better. I will show you also some pictures how we are working with my students, and also I can share with you the link for the project what we were preparing, and if maybe to the chat, I will send it. And anytime you can download the files for 3D printing. So here you can see how it works on a 3D printer, and also some pictures of my students, and that we were really using 3D printed models actually from GeoGebra, because these polygons were made in GeoGebra, and how we were working with it within the mathematics classrooms, mathematics instructions. So here students were searching for tilings, and then they were using this construction set of polygons, and they were able to find more tilings than when they were working just without any visual aid. So also here you can see, I will show you some more pictures of using these models when they were trying to find some relationships in 3D space. And again, these were models from 3D printer. Maybe for the last, I will show you this model, if you can see it on the camera. I just modeled this for teaching the topic of conic sections. So here you can see all conic sections on the cone. So circle, and the model can be put into the parts, so you can really see what conic sections you can get there. So also, I think, very nice instructional tool for teaching mathematics. And also, again, you can model this in GeoGebra. Okay, so I think that's it. Thank you for your attention, and I'm ready for the questions.
Hello, Petra. So did we finish with, is there any questions?
I can maybe show you some more
Oh my God.
models here.
Okay.
Here are hyperboloid, but not rotational. So you can see here is a paraboloid, rotational paraboloid. Or here I have a non-rotational paraboloid. And everything can be used, can be modeled in GeoGebra and used by students in the classroom. And what I really like are these tessellations, Escher tessellations, that you can really see actually the geometry in practice. What has to be satisfied that the tessellation works. It's really beautiful, beautiful geometry. And everything in GeoGebra, and I think it's very easy for students to model it, and it's perfect to use it.
Okay, thank you so much, Petra.
You're welcome.
Thank you so much.
So I'm sharing the constructions in the plane. It's still on the web, so you can see it. And if you want to,
I don't see that you are sharing the screen.
Actually, not sharing screen, but the link for my presentation from the last year.
Okay,
But also I can send you this link for the STL files. If you are interested, you can download the STL formats, and you can get the digital models for printing if you want.
Thank you so
it's
much.
In Czech, but I think you will understand.
Maybe in the future we can spend some a little bit more time with how to do the 3D prints, because I think there's a lot of people who could be interested.
Sure.
And it's connected with geometry, of course, so much.
Yes. Actually, I'm dealing with this a lot. Actually, nowadays I'm really doing 3D printing, so I can share my experiences with you.
That would be wonderful. That would be wonderful. Thank you so much.
You're welcome.
Thank you, Petra.
Thank you too.
So we are stop recording this part and